In college algebra, we wrapped up this 3.3 handout over long division and synthetic division. So let's practice or finish it up. Number 3, we skipped earlier. And what you need to do is you need to put this piece under the dividing part if I'm doing long division. And when I start to do it, I start writing the terms, but hopefully you notice there's no x squared term. I need to put a placeholder in place of x squared, because if I don't represent that x squared, I'm going to get a wrong answer. Every place value, like when you were dividing in elementary school, had to be represented, and the same is true for each exponent. So I need to write 0x squared here, and then plus 3x minus 5. Same with what I'm dividing by. There's not a ones place right here, so I need to write plus 0. So 3x squared minus 2x plus 0. Now, when I divide, or I'm trying to figure out what to divide by, or what the result is, I need to look at this spot, the blank spot, to multiply and get this spot. So the two underlined spots need to be able to multiply to get the circled term. And that should be 2x squared. Because when I go 2x squared times that, I get 6x to the 4th. Now I also have to distribute to these two, but it's that first one that tells me what to multiply by. All right? The others just happen. So I end up with negative 4x cubed plus 0. The next thing you need to do is flip your signs. So minus, plus, the 0 doesn't really matter. And you know you did it right if you get a 0 right here. I usually don't write that, but they should cancel each other out. I get 9x cubed plus 0x squared, and then I need to drop that 3x down. All right, next I am looking at this spot times blank gives me 9x cubed. Hopefully you just said 3x. 3x times 3x squared is 9x cubed. Then I get negative 6x squared and 0. Flip your signs, and we get 6x squared plus 3x, and drop that negative 5 down. All right, the last thing I need to multiply by is 2, because 2 times 3x squared gives me 6x squared minus 4x plus 0. Flip your signs, and you got it. So the answer is written in two ways. First off, it is not a factor because we have a remainder. But they may also ask you, what is the result when you divide 3x squared minus 2x into that? So I literally call this the result. And I write what we got on top. But I also need the remainder. And the remainder you write kind of like back when you did a improper fraction to a mixed number in elementary school. So you take the remainder, put it in a fraction, and you write it over what you divided by. Very similar to back in the day when you divided, for example, 11 by 2. That goes into 11 5 times with 1 left over. So it's very similar to that concept right there. The remainder needs to go over what you divided by. All right, let's work one more problem from this piece of paper. We're going to do synthetic division, but this question is asked very differently. It just says to solve it. Look at number 4 and 5. It phrased it way differently. On number 4, since I was checking for x plus 3 as a factor, I put -3 in the bracket. And then I wrote my front numbers. And I solved this thing. All right, did synthetic division. We need to do the same thing, but they ask it differently. This is implying that x minus 3 is a factor. Oops. So it's kind of like they've already flipped the sign for us. I already know I'm going to get a remainder of 0. So this time it's not a question of x minus 3 being a factor. The question is, what do I get when I divide by x minus 3? So we're going to put 3 in the bracket because 3 is a 0. And you write your front numbers. And you do synthetic division. So the first number drops down. You multiply times the number in the bracket. Combine. Multiply times the number in the bracket. Combine. Multiply. And no surprise, we get 0. They told us we were going to get 0, right? So the important part is this. Because this is 2x cubed, 2x to the third power, I want to take the exponent down 1. So that tells me this result is 2x squared plus 3x minus 2. That is also a factor. That times x minus 3 gives me what we started with. I'm trying to solve this thing. So if I can factor it completely, then I can know all the zeros. So for example, if I put this into 2 parentheses and factor it, I know 2x times x gives me 2x squared. I know a -1 times +2 gives me -2. You can do the box method if you need to factor this thing, but this one was small numbers, so hopefully that's somewhat doable for you. More importantly, this gives you -x. This gives you 4x. And when you combine these, you get 3x, which is the middle term. All right, we're almost done with this one. You take the 2 factors and you solve for x. So this should be review. We've done this many times. And don't forget the one they gave us up in the problem. That's your final answer. So on Tuesday, we took it a step further. And what if they don't tell us this? What if I don't know any zeros and I can't factor this thing? Well, there's this guess and check method that is very tedious, but yet also very handy. And that is finding the possible rational zeros. So what you do is you take your equation and you write down the constant, which is the term without an x. And you write down the factors of that number. So you need to write down any factor. So this includes negatives. Positive and -1 divide into it. Positive and -2 divide into it. and so does positive negative 4. We need the lead coefficient, which in this case is just negative 1. This is the front number. And that one, factors of that one are very easy. Positive negative 1. All right, then at the top of the screen, you have a formula. So I need to take every factor of the constant and divide by every factor of the lead coefficient and list them all out. Now this is really easy because the factors of the lead coefficient are plus minus 1. That means when I divide all those constant factors by plus minus 1, there's no change. So I just write down the factors of the constant. This isn't always the case. Look at number 2. We have a 15 as a front number. That's going to change things. So let's move on to number 2. So by the way, these are the possible rational zeros. Maybe I should write this. So this is a summary of what we just did. I took the factors of the constant divided by the factors of the lead, and I just got what I started with. All right, let's try number 2, and we'll stop with that. So on number 2, I write down my constant. That's negative 2. Factors of negative 2 are plus minus 1, plus minus 2. Factors of the lead, 15, are plus minus 1, plus minus 3, plus minus 5, and plus minus 15. So some people can just do this all in their head and just list them all, but you risk missing one. So what we're about to do is we're about to take all the factors of the constant and divide by all the factors of the lead. So this isn't necessarily mathematically correct, but that's what we're about to do. All right? Looks like we're going to get 16 answers. All right, so when I divide by 1, I just get the original list. When I divide by 3, I get fractions. When I divide by 5, I get more fractions. When I divide, let's finish that, sorry. And when I divide by 15, I get some really ugly fractions. And looks like I guessed right. We have 16 answers. There's 8 numbers there with plus minuses, so that means there's really 16 answers. All right. Very tedious. You just walk through the factors and you divide. All right, we'll do more in the next lesson. See y'all later. Bye.